Good afternoon to all. Good afternoon to all. Please join fast. So today, before I start the class, I will send the link to you because for me today it is little bit difficult to send the link. So I will send it to you first. My link of attendance. And then today's class is little bit special for you. Today we are celebrating the Fibonacci day. Do you know what is Fibonacci? Anybody? Do you know what is Fibonacci? Yes. What is Fibonacci? Anyone? It's a so I have sent you the attendance link. Now what you observe, look at that, what did you observe here? Now what did you observe? Look at the number first. What is date today? Fourteen, 7, 21. See the number. Can you see any pattern in this? Today's date you can see is there is any pattern in this? In the date? What pattern? Today's date is in the type of pattern. What pattern did you observe in the today's date? We learned many type of patterns in previous classes. So what pattern did you observe here in today's date? See, the number is 7 table is there. Okay, half correct. It is half correct. Good, Gaurav. Anything else? 7 plus 7 into 2, 14, and 7 into 3, 21. But if you see the sequence, good for that also. See the sequence, 14, then 7, then 21. 14 plus 7 is equals to 21. Very good, sir. Very good. So the sum of two previous number is the third number. Good observation, Shreya. This is the Fibonacci. This is the Fibonacci sequence. Fibonacci sequence in maths. Today's date, we are celebrating the Fibonacci day, or we can say it is Pi day also. This is like we are celebrating Maths Day and others day. Today we are celebrating Fibonacci day. Okay, so let's see first what is Fibonacci. For you, I am going to play a video, and meanwhile I will stop and I will ask you something. What did you observe? First you understand this, because these Fibonacci numbers you will get to know in the senior classes, and this will help you to solve the problems. So let's see.
Have you ever counted the number of petals on a flower? If you counted them on a flower with petals all intact, you would likely discover that the number of petals is a Fibonacci number, that is, a number from the Fibonacci sequence. Many flowers have 3, 5, 8, 13, or 21 petals, all of which are numbers in the sequence. The leaves of cacti and the seeds of sunflowers are arranged in both left and right-handed spirals. The numbers of seeds or leaves in these spirals are also generally in the Fibonacci sequence. We have 2 hands, both of which have 5 fingers, and each finger is divided into 3 parts. All of these numbers are also Fibonacci numbers. Moreover, the lengths of the bones in our hands also fit into Fibonacci ratios. So, what's the Fibonacci sequence anyway, and why is it seemingly everywhere? The Fibonacci sequence is a series of numbers in which a given number is the result of adding the 2 numbers before it. So, if you start with 0, the next number will be 1, followed by 1, followed by 2, followed by 3, and so on.
So, the small part I have shown it to you. So, what did you observe in the video? Anyone? Anyone? See, the sequence what we have seen is a Fibonacci sequence, and you can see that in the video the flowers, some flower has 3 petals, some has 5, some has 8, some has more than 8, that means 13, and like that are there. We will not get the flower which has 7 petals. Okay, so the flower is always having a sequence type of patterns. Even our bones of hand or other bones of the body parts are also designed in a sequence that is called Fibonacci. Fibonacci is what? Fibonacci start with 0, 0 plus 1 is 1, then 1 plus 1 is 2. See, as the sequence you have seen that. I'll play it once again to there, and then I will stop it for you.
In which a given number is the result of adding the 2 numbers before it. So, if you start with 0, the next number will be 1, followed by 1, followed by 2, followed by 3, and so on.
As you can see here you can see this is 0, 0 plus 1 is 1, then 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and 5 plus 8 is 13, 13 plus 8 is 21, and 13 plus 21 is 34. Like this the sequence is increasing. This is the pattern given in Fibonacci sequence. The Fibonacci sequence work like this only. The sum of previous 2 number is the 3rd number. Always. कोई भी 2 नंबर जो है उसके पीछे उन आगे के 2 नंबर को अलग ऐड किया जाए और तीसरा नेक्स्ट नंबर आपको मिल जाए, तो it is matching to the sum of the numbers, then it is called Fibonacci sequence. Let's see again. Fibonacci is all around the nature. Okay, and you can
see, every number in this series or sequence is obtained by adding the 2 preceding numbers. Individual numbers in the sequence are often referred to as Fibonacci numbers. Mathematically, the Fibonacci sequence is represented by this formula.
See the formula. F function means n represent the number. So f into n minus 1 plus f into n minus 2. This is the formula for a Fibonacci sequence. See how it works.
Where n is greater than 1. You can use this expression to find any nth digit in the sequence. This fascinating sequence is widely associated with the mathematician Leonardo Pisano, also known as Fibonacci. He hailed from the Republic of Pisa, which is why he is also known as Leonardo of Pisa, and is considered to be one of the most talented mathematicians of the Middle Ages. At the time, Europeans were still using Roman.
Please listen the video and remember the names and all these things, because after this I will conduct a quiz for you. So be ready for the quiz. Okay, so please listen the video carefully. I'm just taking a little bit back for you so that you can understand and then you can answer properly in the quiz. Okay.
This fascinating sequence is widely associated with the mathematician Leonardo Pisano, also known as Fibonacci. He hailed from the Republic of Pisa, which is why he is also known as Leonardo of Pisa, and is considered to be one of the most talented mathematicians of the Middle Ages. At the time, Europeans were still using Roman numbers, while Hindu-Arabic mathematicians were using a different number system that was more robust and efficient. Fascinated by the brilliance of the Hindu-Arabic numeral system, Fibonacci brought it to the Western world in 1202 through his now famous book, Liber Abaci. In the book, he reviewed and compared the Hindu-Arabic numeral system with other systems, such as Roman numerals, and described how using the Hindu-Arabic system made calculations faster and easier. Although his book contains the earliest known description of the Fibonacci sequence outside of India, it was described in ancient Indian texts by mathematicians as early as the 6th century. So, what makes the Fibonacci sequence so special? To the uninitiated, this famous sequence may just seem like a series of numbers, but the Fibonacci sequence has been discovered and rediscovered in various forms, not only in mathematics, but also all across the natural world and in our everyday lives.
See, the Fibonacci sequence is not only there is in the mathematics, and it is there in all around the nature, even in the eggshells. Here you can see on this part of the seed, then in a snail cell, inside the flower pattern. If you can see this pattern, this is Fibonacci. This she-horse, this elephant, this flowers, even though in the cauliflowers and other flowers also, vegetables, we can use it for music. This sequence is also working for the music, and even though for the pure sports, ground and other things is also working. See, let's see.
There's also another exciting offshoot of the Fibonacci sequence, the golden ratio. Suppose you have two quantities, A and B, wherein A is greater than B. Now, add A and B and divide that sum by A. If this ratio comes out to be equal to the ratio of A and B, then you can say that A and B have a golden ratio, which is represented by the Greek letter phi. Write down the Fibonacci sequence on a piece of paper and calculate the ratio using this formula. You will notice that all Fibonacci numbers have the golden ratio, the value of which is close to 1.618033.
This is the golden ratio of all Fibonacci numbers. What it is coming? 1.618033. Okay, this is the golden ratio of all the Fibonacci numbers. You can take any Fibonacci two numbers and then you find out the ratio. You will get only this as a ratio solution. Okay.
In geometry, when the golden ratio is applied as a growth factor, you get a special type of logarithmic spiral, known as a golden spiral. Simply put, a golden spiral gets wider by a factor of phi for every quarter turn it makes. You can find examples and manifestations of the golden ratio and golden spirals in countless places in your everyday life. Seashells are some of the most common examples of the golden spiral found in nature. But ocean waves, hurricanes, flower buds, snail shells, and spider webs are just a few of the other naturally occurring examples. Many artists use the golden ratio or the golden spiral in their creative works. Legendary painter Salvador Dali explicitly used the ratio in his masterpiece, The Sacrament of the Last Supper. Architects also commonly use the golden ratio when designing buildings and other massive structures. Popular Swiss-French architect Le Corbusier, who is widely acclaimed as one of the pioneers of modern architecture, explicitly used the golden ratio in his modular system. From snail shells, flowers, and bananas to the inside of the human ear, iconic buildings, and galaxies far out in the cosmos, the golden ratio can be seen everywhere. This is probably why it's also known as the divine proportion. There are so many places to find the golden ratio or Fibonacci numbers that it's impossible to list all of them in one place, and the list is ever growing. What other examples of the Fibonacci sequence or the golden ratio have you observed in your life? Tell us in the comments below.
So, you have seen this? One more video I am going to show you. Okay? Just look at this video also and then we will.
Good grammar and spelling are important, but if you want to write S
So why do we learn mathematics? Essentially for three reasons.
See, this is the creative video I am just showing it to you. You can see it on
and unfortunately least in terms of the time we give it.
your maths after the maths class.
The science of
okay, in
patterns, and
YouTube,
you study it to
and
learn how to think logically.
as it has the copyright, so I am just closing it.
But too much.
Okay, let's start the quiz. Now tell me this next number, what will be the next number here? What will be the next number here? As per Fibonacci sequence, what will be the next number here? Some are telling 6, some are telling 9. ऐसा थोड़ा, I said as per Fibonacci number. 4 plus 5 is equals to 9. Okay. Then what will be the next number? After 9, what will be the next number? Come on. After 9, what will be the next number? Good, Ayushbari. Yes, 14 is that. Then 4 plus 5 is equals to 9. Then 5 plus 9 is equals to 14. Then after 14, what number should be there? So that we need to add the first two numbers just before the numbers. 23. Now understood everyone. Okay. So let's start a quiz. Okay. All are ready for the quiz? Huh? So, shall I start? Join fast, everyone join fast. Join the quiz by using the link. Only 6% has joined. Come on, join fast. 19 are there now. Join fast. I have started the quiz. Go. As you can see, the screen is showing who is giving the right answer and who is giving not the right answer and who is scoring what. So please look at the sequence properly. As you give the answers, the screen is changing. Who are the top scorers? I am showing the screen for the top scorers. Here Himanshu is leading now. Yes, some of you are there, those who did not score at all. Shreya, you did not play any questions. You did not write the answer of any of the questions. Shreya? So Hers and Himanshu are now equally 8 questions. They gave the answers. Now Hers is reading. Here Palak is reading near to there. Palak Madastar. Good competition is going on between 2 people. Shreya, I don't know what you are doing. all the 10 questions. As we give the answer, the point is increasing. Let's see the questions. Here in the first question we can see 14 correct and 13 incorrect answers. So the answer of the first question is 2 plus 3 is 5, 3 plus 5 is 8, then right after that 8 plus 5 is 13. Okay, so the answer for the first one is 13. Now here 4 plus 5 9, 9 14, then 14 plus 9 is 20, we did it. Then 10 plus 12 22, 12 plus 22 is 34, 34 plus 22 is what? 56. That answer is 56. Now let's see the next answer, fourth answer. 8 plus 13 is 21 and 13 plus 21 is 34. Okay, the answer is 34. Here 100, 200, 300, 200 plus 300, 500, then 500 plus 300, 800, then 8 plus 5 is 1300. Now sixth one, 59 plus 55 plus 29, 144 277, what should be there? Here 610 is the answer for the sixth one. For the sixth one, the answer is 610. Very good. Then seventh answer you can see here. Dash, dash, back you have to go. Here 5 and then 3. 3 and 5 is the answer, second one. Got this. Then here 13 and 8. 13 and 8 is the answer here. Now 89, 44, what should be there? A 233 will be there. Now here the last question, 10th question. 6, 12, 18, 30, 48 is the answer. So I think everybody has learned the answers. So I am ending the quiz now. I have ended the quiz. See your book. See here it is showing that Karthik is the first, second is Himanshu and third is Murchandani. And see Palak they have given you people have got this 100% scores, 90% score, 100% score, and well done to all of you. Well done to all of you. And just exit from here. And I am closing the class for today. Thank you and have a nice day to all of you. Okay. Yes. So I think all of you have got the attendance link and everything. So you might have filled the attendance. Yes, I showed the name in that. Ah. So how do you feel? Did you feel you enjoyed the today's session? Did you enjoy the today's session? So thanks to all. Bye. Bye for today.